Hello my dear PU1 students, here I am to help you with your FA2 exam and I am going to discuss the most important questions for your FA2 exam of physics. Obviously, those who don't know me, I am Shomik sir. I teach physics in Deeksha Karnataka YouTube channel. Now, if you are watching this channel for the first time, I request you to subscribe to our channel and also join the WhatsApp channel if you want the solution in a written format, in a PDF format of the entire question paper. Now, what we are going to discuss here today, as I mentioned, I will be discussing the FA2 most important questions that will include some MCQ questions, fill in the blanks question and numerical questions as well. So let us first look into the chapters that we are going to discuss today. The chapters that we are going to discuss today are gravitation, mechanical properties of solids, mechanical properties of liquids and thermal properties of matter. Now I know these chapters tend to be little difficult for many of you because most of the time you don't study these chapters and the content of this chapter can be difficult at times, but you have to remember the chapter gravitation is very important. It is not only important for your FA2 exam, but it is also important for your final PU1 exam. Okay. So if you study a little bit now, then the problem of you have to study over and above during your PU board exam that you don't need to, PU1 exam that you don't need to do. Okay. So again, next year your PU2, so you have to start preparing from now onwards, right? So without any delay, let us start with the MCQ questions first. The dimensions of universal gravitational constant G is. This is one of the most asked question from this chapter as well as in your PU exam. So dimension of universal gravitational constant G. So how you can find the dimension? Okay, only I always request you to remember one dimension, that is dimension of force. Okay, if you remember dimension of force, then most of your quantities can be related to force somehow, and if you can do that, then you can find the other quantities dimension. So what is the dimension of force? Dimension of force is ml t to the power of -2. This is the dimension of force. Obviously, other than that, you have to remember the dimension of all the fundamental quantities and some cases area, volume, which are very obvious, right? So in this case, the dimension of force is ml t to the power of -2. What dimension we are finding? Which is gravitational constant G. So what is the relation of gravitational constant G with force? Obviously, our Newton's law of gravitation states that F is equal to G m1 m2 upon r square. What is r square? R is distance, so r square is distance square, right? Now we will put the dimensions of each quantities on off here. So F, as I mentioned, is ml t to the power of -2. This is the most difficult dimension I ask you to remember. Obviously, good students always remember this, but again, if you want to find the dimension of any unknown quantity and if you are not good with memories, then you have to remember one of the fundamental dimension, that is force. Okay, all other quantities can easily be related to force. Now we are trying to find the dimension of this quantity G. What is the dimension of mass? Dimension of mass is simple m. How many masses are here? Here we have m1 and m2. That means we have two masses. So mass into mass, so it will be m square over here. What about r square? I told you r is nothing but distance. So distance square means the dimension of distance square will be l square. Right? Now do the cross multiplication to find the dimension of G. So what is the dimension of G? Dimension of G is m l t to the power of -2 into l square divided by m to the power of 2. Same mathematics that you do for in normal calculations, same you can apply in dimensional related questions as well. So now simplify, you will see that m to the power 1 is here and 2 is in division. So the dimension, the complete dimension will be -1, 1 minus 2, right? Now L1 is here and L square is multiplied. That means L1 into L square will be L to the power of 3. And t, there is no other t, so t will remain unchanged, that is t to the power of -2. So we got the dimension m to the power of -1, L cube t to the power of minus 2. So option D is correct answer. Sometimes they might give you the unit of this gravitational constant as well, so prepare the unit as well as dimension for this quantity. This is one of the most asked question based on the concept of G. Sometimes they will ask you the value of G as well. Okay, value of G is 6.67 into 10 to the power of minus 11 SI unit. Okay, now let's move on. When the earth is closer to the sun, earth moves faster, moves with same speed, moves slower, moves with constant acceleration. So we know that earth and sun are not a complete circular path. Actually it's an elliptical path. So sun is located in one of the foci and earth is rotating in the elliptical path, right? So when the earth is closest or closer to the sun, that means in the perihelion region, what happens here? The earth moves faster, and that comes from the Kepler's law of motion, law of area. Okay, the area subtended in a fixed amount of time has to be constant. Now here, because this distance is small, it has to move faster to cover a large distance, whereas when it is in the farthest area, okay, it can move slowly to cover the same area. Okay, so it can be said that when the earth is closer to sun, it is moving faster. Okay, also it can be we can say it from the Newton's law of gravitation. Distance is smaller. Distance smaller means more amount of force, right? It is inversely proportional to distance. So more amount of force, less distance means more amount of force. More amount of force means higher acceleration. Higher acceleration means higher speed. Okay, so moves faster when it is closer to the earth, and it moves slower when it is further from the sun is further from the earth. Okay, now next question. Which statement best describes Newton's law of gravitation? Easy enough. It applies only to objects on earth. Is it? No, it is applied to all the objects. It is limited to interactions between planets. No, it is between planets, even between galaxies also. This law is valid. It is applicable to all objects with mass in the universe. Yes, this is the correct statement. It is applicable to all objects with mass in the universe. That's why it is called universal law of gravitation. Okay, that is why it is called universal law of gravitation. Now, before I continue, I just request you once more that if you have not yet subscribed to our channel, first of all, subscribe. The subscribe button is there, and also if you want the PDF of this lecture and all the updates that is going to come in your way, don't forget to join the WhatsApp channel. The WhatsApp channel link is given in the description section of this video. Okay, now let us continue. The acceleration due to gravity due to a hollow spherical shell of uniform density at a point inside it. So, acceleration due to gravity of a hollow shell. Hollow shell means, what is the meaning of hollow shell? Hollow shell means it has nothing inside. Okay, so nothing is inside, everything is outside. Okay, shell means it's like a cover of an egg. If you have seen an egg or orange peel, I hope you have eaten orange peel. So suppose you are peeling an orange, but you find that inside there is nothing, no orange is there. Okay, someone eat the orange and they put the cover outside like that. So that is called a hollow shell. So nothing is inside. So if you peel it, you will see nothing inside. Inside is completely empty. Okay, those who play tennis ball, they will know the cover of the tennis ball is hard, but inside the tennis ball it is completely hollow. So that is also an example of hollow shell. Okay, now inside the hollow shell, if you construct an imaginary circle, how much mass it encloses? It encloses zero mass. So inside the hollow shell, the mass is not there. If mass is not there, there will be no force acting on it in the object. All the forces that is acting by the outside objects will be cancelled, and the net force will be zero. And as the net force is zero, the gravitational acceleration will also be zero. If earth is hollow, if suppose the earth was supposed to be hollow planet, so inside the planet is hollow, nothing is inside, then if you go deeper, then there will be no gravity, you would have been floating. Okay, but that is not the case because the earth is not hollow, it is solid, right? So the gravitational acceleration inside a hollow object is zero. Next question. Now, next chapter, Poisson's ratio is the ratio of longitudinal stress to longitudinal strain, volume stress to volume strain, lateral strain to longitudinal strain, longitudinal strain to lateral strain. So Poisson ratio, first of all, it's a dimensionless quantity. So because it's a dimensionless quantity, it cannot be stress by strain. Okay, stress by strain gives you Young's modulus, volume constant, etc. Right? So it cannot be the stress by strain ratio, which is a dimension, that is a quantity with dimension. It has to be a ratio of two similar terms, and you have to remember that Poisson ratio is lateral by longitudinal. Lateral by longitudinal. So it is lateral by longitudinal, both are strain. Both are strain. Okay, strain itself is a dimensionless quantity, so it is a ratio of dimensionless quantities itself. Okay, so a Poisson ratio, that's why it is called Poisson ratio. It is the dimensionless quantity. Okay, so lateral strain by longitudinal strain is called Poisson ratio. So correct answer is option C. So this is a question. This chapter onwards, the questions will be more of memory based rather than calculation based. Okay, gravitation is slightly easier in my opinion, because you can figure out the answer even if you have not studied a little bit. If you have a basic idea, you can answer. But in case of the chapters that are going to follow, that is mechanical properties of solid, mechanical properties of fluids, and even thermal properties, you require to know a little bit of theory to answer those questions. Now, the stress that can change the volume of the object without changing its shape is compressive stress, tensile stress, shear stress, hydraulic stress. Okay, so here we are talking about the stress that can change the volume of the object without changing its shape. Okay, so if you compress an object, okay, its volume decreases. Okay, now hydraulic stress is also kind of stress which changes the volume. Shear stress, it is basically rotating the object, so its shape is getting changed. Okay, and tensile stress is something which does not change its shape, so it can change its volume. So tensile stress, even if it is getting elongated, it is getting slightly changed in shape. So you can say that tensile stress can be one stress that cannot that can change the volume without changing its shape. Now next question. The approximate relationship between Young's modulus and rigidity modulus is, so Young's modulus and rigidity modulus given by the formula G is equal to Y by 3. Okay, so G equals to Y by 3 is the relationship between Young's modulus and rigidity modulus. Rigidity modulus is given by G, Young's modulus is given by Y. Approximately this is the relationship. It is actually Y equals to 2 plus 1 constant into G. This is the approximate formula, but for most objects you can take n equals to 1, and if you take n is equal to 1, then you will get G is equal to Y by 3. Remember that G is smaller than Y. Okay, that's why it is 1/3 of Y. Okay, now next question. The maximum load a wire can withstand without breaking when its length is cut into half of its original length. So you have a wire. Okay, it can say maximum load it can take is say F max. Okay, now if you cut the wire into half, okay, so that means the length is now L by 2. How much maximum force it can withstand? Now you have to remember that the maximum force that any wire can withstand is basically given by the depends on the area of the wire. It is independent of the length, it depends on the area of the wire. Now because you just cut it into half, that means the area of the wire remains same. So if area of the wire remains same, then it will, the maximum load it can support without breaking will also remain same. So this is a very trick question. It will remain same, it will not change. Okay, so if you just simply cut a wire, if the previous wire can used to hold say 2 kilograms, the new wire will also be able to hold 2 kilograms as well. Okay, so it will remain same. Next question. Which one of the following statements is wrong? So there are 4 statements, you have to find the wrong statement. Very tricky question. So here 3 of the statements will be correct, only 1 of them will be incorrect. That incorrect one you have to select. Solids have definite shape while liquids and gases do not have definite shape. Yes, this is the correct statement. The volume of any substance depends on the pressure acting on it. Okay, volume of any substance is slightly dubious because solids generally do not change when acting under pressure. But let's see. Solids and liquids have lower compressibility where compared to gases. So solids and liquids generally do not compress, gases do compress. That's why the compressibility of solids and liquids are less. So this is a correct statement as well. When compared to solids, fluids offer large shear stress. When compared to solids, fluids offer large shear stress. Shear stress means what? Now here the term fluids refer to liquids as well as gases. What is the shear stress? Shear stress is like you take a book. If you apply some side wave pressure on the book, then the book gets tend to bend, right? That is called shear stress. Suppose you have a book like this. Okay, now if you apply a side wave force, then what happens? The book generally gets to become a wedge, right? This is called shear stress. Okay, now for fluids and especially liquid and gases, the shear stress is minimum. Okay, it is very, very small. So when compared to solids, fluids offer very small shear stress. This is the correct answer for this question. Okay, this is the wrong statement. But what about this one? So here, even though the statement is not perfectly true, okay, volume of any substance, I have some conservation about the term any substance, because if it is a solid, then their change in volume is almost negligible, but not zero. Okay, so even if they said volume of any substance depends on the pressure acting on it, it can be partially true. Okay, so that statement can be accepted as true, correct statement. But this exact question may not come in your FA2 exam, but you should be aware that in some cases you have to choose the more wrong answer than the more correct answer. Okay, so here this is slightly okay. This statement is slightly okay. This statement is completely wrong. So that's why we have chosen this as our correct answer. Now next question. The pressure in a fluid at rest is the same at all points if they are in the same height. This is the statement of Bernoulli's principle, Pascal's law, Stokes' law, or Hooke's law. This is the statement of Pascal's law. Okay, same height means the region will be same. That means the pressure at all direction, the fluid exerts same pressure, which is basically Pascal's law. Okay, Bernoulli's principle is completely different. Stokes' law is also not true over here. Hooke's law is for solid. Okay, now let's move on. If the area of cross section of a tube of flow decreases, then the rate of flow of the fluid through it. So if the area of cross section decreases, then what happens to the flow? Flow increases. Okay, because from the equation of continuity, area into velocity is constant. That means A1 V1 is equal to A2 V2. So if suppose A2 is less than A1, that means area is decreasing. To keep the quantity constant, V2 has to increase. I am giving you one example. Suppose initially the area was say 2, but velocity was say 1. Okay, so area was 2, velocity was 1. What is the multiplication? Multiplication was 2, right? Now, in new case, the area is reduced. Say now the new area is 1. Okay, 1 meter square. So the area is reduced. What will be the new velocity then? What will be the new velocity? So if you calculate, the velocity will be coming out to be 2 meter per second. That means as the area decreases, the velocity has to increase. In some cases, if you don't understand, if you know the theory but you don't understand how to answer it, take real values, put them in the equation and check if it is giving you any correct result or not. So based on that, you can say that the flow of fluid should increase in this particular case. Now next, dynamic lift due to spinning. Dynamic lift due to spinning is called Pascal's law, Magnus effect, surface tension, viscosity. So when you spin something, it automatically started going up, which is called Magnus effect. Okay. If you are a fan of cricket and if you watch spinners, a spinning bowler is bowling, okay, there is a term they use that the ball is flighted. Okay, what is the flight meanings? Generally the bowlers, when they bowl from a certain height, but because of the spinning, the ball tends to go little bit higher than it's supposed to go. Okay, and that is happening due to Magnus effect. Now in case of cricket, the Magnus effect is not very stark, but in some cases Magnus effect can be utilized. We will see in some in future videos Magnus effect and its application. Okay, so Magnus effect is when something is spinning, it tends to grow up. Okay, the object rises, which is called Magnus effect. Remember the term. Okay, there is a person called Magnus Carlsen, and if you know who is Magnus Carlsen is, please mention that in the comment section below. Now next, question number 13. The temperature at which same value of measurement in Celsius and Fahrenheit scale. This is one of the oldest question. So the temperature at which both Celsius and Fahrenheit are equal is at minus 40 degrees. So minus 40 degrees Celsius is equals to minus 40 degree Fahrenheit as well. Okay, at minus 40 degree both scales match. Next, at atmospheric pressure the water boils at 100 degrees Celsius. If pressure is reduced, it will boil at higher temperature, lower temperature, at the same temperature, at the critical temperature. So when you object generally boils at 100 degrees Celsius, so if you reduce the pressure, then the object will start boiling at lower temperature. Okay, pressure reduction decreases the boiling point. Okay, it will boil at lower temperature. Similarly, if you increase the pressure, it will boil at higher temperature. For example, the pressure cooker. Pressure cooker is a device where you increases the pressure, and because of that, the it boils at higher temperature and our food gets cooked easily. Now, last MCQ. The temperature of stars is determined by Stephen's law, Wien's displacement law, Kirchhoff's law, Newton's law. So temperature of stars are actually determined by Wien's displacement law. Okay, the lambda that we observed, the lambda max, okay, that we observe from a distant star, lambda max is the wavelength of light which is coming from the distant star, and its temperature, okay, is a constant. Okay, it's a constant, and that constant can be calculated from some observation on Earth from our own objects. Okay, where lambda is known, temperature is known, and you can calculate the A. Now you can apply the same formula for a distant star, and you can observe the lambda max by using telescope, and then you can find, okay, this must be the temperature of the object. Okay, so by measuring lambda max, you can find the temperature of the star, which is Wien's displacement law. Now next is fill in the blanks. This can also be tricky if you are not prepared enough. So whenever I tell my students to when they are answering fill in the blanks, make sure that the sentence is making a sense. Okay, so you have to make sure that the sentence is making a sense. If it is not making a sense, possibly it can be a wrong answer. The gravitational potential due to Earth at a very large distance is dash. So the gravitational potential due to Earth at a very large distance is 0. Okay, because gravitational potential is inversely proportional with distance. What is the formula for gravitational potential? Gravitational potential is minus Gm1 m2 upon r. Okay, this is not gravitational force, it is gravitational potential energy or gravitational potential. Okay, for any object this is given by Gm1 m2 by r, and for any object it is at very large distance, that means r almost tends to infinity, and if r tends to infinity, that means gravitational potential becomes 0. So correct answer is 0. The phenomena, and also whenever you answer some question, if you see this is answered, mark it. Okay, the phenomena in which the freezing of ice when pressure is removed. So when you remove the pressure, the ice gets refreezing. Okay, so suppose you applied high pressure on ice. Okay, it starts to melt, and if you remove the pressure, then the ice becomes solid again. That is called the term is called regulation. Okay, regulation is the process where you can apply pressure, melt the ice, and then remove the pressure to join them again. There was one famous experiment of iron wire and some weights. Okay, if you put that, the iron wire will cut the ice, but the ice will still stay intact because of this regulation property. Okay, so the property is called, or phenomenon is called, regulation. Lateral strain is equal to dash into longitudinal strain. We have solved this question before. So lateral strain is equal to dash into longitudinal strain. Here it will be Poisson ratio. Poisson ratio is lateral by longitudinal. So this is Poisson, okay, not poison that we that is harmful for us. Okay, this is not poison. Okay, this is Poisson. Okay, Poisson ratio is lateral strain by longitudinal strain. So lateral strain must be Poisson ratio into longitudinal strain. Now drops and bubbles are spherical. So what are all the options we have covered? Poisson ratio is also covered. Okay, drops and bubbles are spherical because of dash property. So drops and bubbles, they are spherical. So when raindrops are falling, they appear to be spherical. Even a water drop, if you take the water drop, it appears to be spherical because of the surface tension. Surface tension always tries to keep the minimum possible surface area. That's why it is spherical. So surface tension property is the correct answer. Okay, the steady wind blowing from north to east to equator near the surface of the earth is called dash. So if you see, there are two options, sea breeze and land breeze. Both can be option over here. Both can be answer to this question, sea breeze or land breeze. So you have to remember this is called sea breeze and not land breeze. Okay, north to east is called sea breeze. Okay, north to east is called sea breeze. Okay, sea breeze, there is one more definition, that at night, at day and night, during the day sea breeze starts coming out from sea to land, and during the night water comes from during the day land breeze comes. Okay, because land becomes hot and air pressure reduces, so sea breeze coming from sea towards the land, and during the night opposite happens, land breeze goes from land towards sea. Okay, that is also sea breeze, land breeze. But here from north to east in the equator during on the near the surface of the earth is also called sea breeze. Now next move on to the chapter gravitation, all 2, 3, 5 marker questions from this chapter. From this chapter we are expecting in FA2 that at least one 5 marker long answer type question or one 5 marker numerical question or both. Okay, in some colleges they will be giving both questions from this chapter. This is one of the most important chapter. Okay, so 5 marker numerical or 5 marker long answer type question, both are possibly going to come from this chapter. So this is the most important chapter and we will put more effort on this chapter only. Moon has no atmosphere. Why? Okay, the moon has no atmosphere because its gravitational force is very weak and low escape speed. This is a very important term to mention in this answer, low escape speed of the gases. Okay, so all the gases, so for example, what is atmosphere? Atmosphere is a cumulative presence of all the gases, right? Air that we say. So air is present all around us, and because of the air we feel the pressure, and that is because the gravity of earth is trying to hold everything together, and the escape speed from earth is very, very high, so the gases cannot escape from earth. Okay, later on you have learned another thing, that is RMS speed. Okay, so RMS speed of gas, if the RMS speed of gas exceeds the escape speed, then they will slowly leave the planet and they will go to the space. So, but for moon, because of weaker gravity, the escape speed is low, so gases could easily escape the surface. Since the moon's mass is very small and it cannot hold the gases around it as they escape into the space due to the low gravity and low escape speed. Okay, so that's why moon has no atmosphere. So you have to write at least 1 or 2 sentences completely so that the teacher will understand that you know the answer. State and explain Newton's law of gravitation. Very important question. Newton's law of gravitation states that, okay, every object in the universe attracts every other object with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between the masses. You can add one more line, that force acts along the line joining the masses. That is, even if you not do that, that is also fine. But these 2 points you have to mention: the force is proportional to the product of the masses and inversely proportional to the square of the distance. Okay, that is very, very important. So mathematical form is F is equal to G m1 m2 by r square. So if this question comes as a 3-marker question, 2-marker question possibly only the statement is sufficient. If it is coming as a 3-marker question, then we will say that write its mathematical form and explain the terms. So mathematical form is G m1 m2 by r square, where F is the gravitational force between two bodies, m1 and m2 masses of the two bodies, r is the distance between the centers, G is the universal gravitational constant. Clear? State 3 Kepler's laws of planetary motion. Very, very important. They can come as first and second law, second and third law, or all 3 law. Okay, if it is a 2-marker question, they might ask state first and second law of Kepler's law. Okay, so all 3 laws are very, very important, so don't miss out on any one of them. Kepler's first law, or law of orbits. Every planet moves in an elliptical orbit. Very easy. The first law is very easy. Okay, every planet moves in elliptical orbit with the sun at one of the 2 foci of the ellipse. Okay, foci is the plural term for focus. Focus is only one, but ellipse has 2 focuses. Focuses we do not say. So the term that is we use is foci. Okay, so 2 foci of the ellipse. Kepler's second law, law of areas. A line segment joining the planet and the sun sweeps out equal areas in equal intervals of time. Okay, so line joining the planet and the sun sweeps out equal area in equal interval of time. Kepler's third law, law of periods. The square of the orbital period t of a planet is directly proportional to the cube of the semi-major axis small r of the orbit. Okay, so t square is proportional to r cube, so that is also law of period. This is the most difficult one to remember, so you have to practice a little bit. Okay, time period is square of the time period is proportional to cube of the semi-major axis. Okay, so this is also very important law. Third law, sometimes they ask you and they ask you to explain it, so you have to mention t square is proportional to a cube. And if say that suppose one planet has T1, another planet has T2, the semi-major axis is A1, semi-major axis is A2, then T1 square by T2 square is equal to A1 cube by A2 cube. And these 3 laws are applicable to any planet and sun system. It is not only applicable to our solar system, this is applicable to any solar system which is there in the universe. Okay, so this is also a kind of universal law. Derive the relationship between small g and capital G. Okay, again it's an easy question, not super difficult. Just you need to know where you have to start and how to answer it. Okay, so we know that from Newton's law of gravitation, F equals to capital G m upon r square. What is the quantities over here? M is mass of earth, m is mass of earth, and r is radius of earth. Okay, so these 2 quantities are there because we are talking about small g. Small g refers to the gravitational acceleration of earth, so that's why you can directly take the mass of earth. Okay, if you do not want to write it anything, then you can add one e over here. Generally me refers to mass of earth and re refers to radius of earth. Okay, so this is the first part. So you have a mass of mass m, and this is earth. This is our home planet earth. So what is the force between these 2 objects? So the gravitational force according to Newton's law is given by this formula, but we also know that any objects when they are falling on towards earth, okay, there is a weight of the object. What is the weight of the object? Weight of the object is given by mg. So this weight mg is also the force, so we can say that F equals to mg as well. The diagram is important. If you draw this diagram, then you do not need to write too many things. If you don't draw the diagram, then you have to write each and every step. Okay, so F equals to mg as well. Now both should be the same force, so we can write mg equals to gm m mass of earth divided by re square, or g equals to g me by re square. So this is the relationship between gravitational acceleration and universal gravitational constant. Okay, so this is the relation that if you do that, mostly 2 marker or 3 marker, both question can be formed from this question. So you should get the full marks. Now next, assuming the expression for orbital velocity of satellite at height h, derive the expression for its time period. Now here you have to assume the orbital velocity, but in case if you forget the orbital velocity, then what to do? I will tell you that method as well. So orbital velocity of a satellite is given by square root of gm by r plus h. This is the orbital velocity. If you remember, it is very good. If you don't remember it, you should have to recall one thing. This is suppose our Earth, the satellite is orbiting at a distance, at a height h, small h. Okay, small h is given. I generally like to use capital H, but here they have given small h, so I will use small h. Okay, so it will be small h. Okay, so when a satellite is orbiting around the Earth, okay, so what are the forces that are acting on it? There is a force of universal gravitational force, okay, that is given by gm m by r square, right? This is the universal gravitational force, but here instead of r, you have to use r plus h whole square, r plus h whole square. This is the universal gravitational force, but because this satellite is also rotating in a circular path, that means it has to have the centripetal force as well, right? By this time I hope that you are familiar with centripetal force and you have already remembered its formula. Okay, so what is centripetal force? It is given by mv square by the distance r, that is r plus h. In this case, instead of all the distances, we will use r plus h. So if you compare these two equations, you can calculate the velocity of the satellite. Okay, so in case you forget the exact formula, you can remember, okay, gravitational force is this is centripetal force, both force should be equal. So from there you can compare and you can find the satellite's velocity. Okay, this is an easy trick to remember. Okay, and if in case they ask you derive the expression for satellite speed of satellite, then you can simply start with this and you can compare these two and find this value. Okay, so this is an easy way to remember. This is a shortcut way, not shortcut way, this is a smart way to remember if you are someone who are good with mathematics but tend to forget the formulas. Okay, so v is equal to gm by r plus h. Okay, now what? So this is a circular path on which the satellite is orbiting. So what is the radius? Radius of the orbit. Radius of the orbit is capital R plus small h. Capital R is the radius of Earth, right? So capital R plus h is the radius of this circular path. So how to find the time period? Time period is basically the time taken to complete one full rotation. Time period is time to complete one full rotation. So speed is known. Okay, now we have to find the distance. How much distance is there to complete one full rotation? The distance covered to complete one full rotation is distance to complete one full rotation is the circumference of this circle. Okay, circumference of this circle. So what is the circumference of a circle? 2 pi r, and as I mentioned, instead of all the r's we will use r plus h. This is the distance that it has to travel to complete one full rotation. So what is the time period t? Time period t is distance divided by velocity. This is the formula for time. T equals to s by v, right? So here distance traveled is 2 pi r plus h and velocity is v. So the time period, because it's only one rotation, that's why this is the time period. If it is 5 rotation, then it will be 5t. Okay, but we are only dealing with one rotation, so this is t. So now let us put the values. 2 pi r plus h divided by square root of gm upon r plus h. Okay, again I am writing capital. Sorry for that, I am used to writing capital. Okay, now what you have to do is just have to simplify this. So 2 pi r plus h, okay, into square root of r plus h by gm, right? It get inverted. Now what? If you take this r plus h inside the square root, what will happen? It will become r plus h whole square. But there is already one r plus h present over here. So whole square into 1, what will happen? So 2 pi square root of r plus h whole cube divided by gm. Now why whole cube? So first step is to take this r plus h inside the square root. So once you have taken this inside the square root, it becomes r plus h whole square. So once it becomes r plus h whole square, then you have to multiply with another r plus h. So r plus h whole square into r plus h will be r plus h whole cube. X square into x is x cube. Similarly here also we have got this. Now square root is common because we have taken this term inside the square root. So this is the formula for time period. Okay, this is the formula for time period. Just for this derivation you can get 3 marks if you do it correctly. Now let's move into the 5 marker long answer type derivations. Derive an expression for escape speed from the surface of the earth. Very interesting and very common question from this chapter. So we have our planet earth. Radius is given by r, mass of the planet is given by, say, let's use these symbols. Okay, mass of the earth is me, radius of planet earth is re. Now what is happening? First of all, when you keep an object on the surface of the earth, why it is staying on the surface of the earth? First of all, let us understand that the object will stay on the surface of the earth because of the potential energy. Okay, potential energy is negative, and because of that negative potential energy, it will not be able to escape the earth. To make it escape the earth completely, okay, we have to provide it with kinetic energy so that it can overcome the potential energy, and it should be it should go to infinity, right? Now on the surface of the earth there are 2 energies. Potential energy, which is given by U equals to minus gm m by so as I have taken me, so let me use me. Okay, so me m upon re. Okay, minus gmm by r. This is the potential energy on the surface of the earth. Now if you give it escape velocity, if you give it a velocity of escape velocity, say ve, what will happen? It will go to infinity, right? So what will be its kinetic energy when you give the velocity? The velocity is on the surface of the earth, by the way. So what will be the kinetic energy? Kinetic energy will be given by ek equals to half m v square. Remember that kinetic energy can never be negative, right? We have learned it in work energy power system. So total energy should be, because it is going to infinity, so going to infinity means its total energy must be 0. Total energy must be equals to sum of potential plus kinetic, and because it is going to infinity finally, so its total energy at infinity should be 0. So when it is going to infinity, that means its total energy is gone, everything is gone, so it should be 0. So that means we can say that minus gmem upon re plus half m v e square must be equals to 0, or half m v e square equals to g m e small m by RE. What is small m? Small m is the mass of this object. Small m is the mass of this object. It does not play any role, but you don't forget it, okay? So mass cancels. So from here we get what we get? We get VE square equals to 2 GME upon RE. So you can leave the answer over here, but there should be careful because it's a 5-marker question. You cannot leave the answer over here. You have to add one more thing, that is gravitational acceleration is given by GME upon RE square. We have derived it, right, in one of the previous derivation. So what we will be doing, we will multiply RE in the division and in the top. We will multiply 2 REs in the numerator and denominator. Okay, so in the denominator what we got? We got by multiplying RE in the top and bottom, we got RE square in the denominator, right, and 1 RE extra in the numerator, right? So now what is this quantity? GM by RE square. GM by RE square is gravitational constant. So we can write that VE square equals to 2G, not gravitational constant, it is acceleration due to gravity, into RE. Okay, so it will be 2G into RE, or VE square, VE equals to square root of 2G RE. Now if you put the gravitational acceleration 9.8, radius of Earth are approximately 6350 kilometer, then you will get the velocity of VE approximately 11.2 kilometer per second. Okay, so this is the correct derivation. If you do it, you should get full 5 marks, but you have to mention why this line is written, why this line is written. Derivation part, after the derivation is done, you don't need to write anything, but you have to mention the potential energy of an object on the surface of the Earth is given by P equals to U GM by minus GM by GMM by R. Now if I want to make it go through escape the Earth, then the velocity is given is V, then the kinetic energy would be half mv square. Now at infinity the total energy must be 0. That means T equals to U plus K equals to 0. These 3-4 lines you have to write, and if you draw the diagram along with them, then you don't need to write too many things. This is one of the easiest derivation, and you should get full marks. Now next, move on to the next question, another 5-marker question. Derive the expression for acceleration due to gravity at a point above the surface of the Earth. So above the surface, below the surface, both are important. Above the surface is easier, below the surface is slightly tricky. So what is the question? Here we have our Earth, okay, and we are trying to find what is the gravitational acceleration at some height, say capital H. Now I will use capital H, okay, I am not going to use small h. Okay, the radius of the Earth is given by RE. Okay, mass of Earth is given by ME. Okay, so first the mass of this object is small m. What we are trying to find? We are trying to find gravitational acceleration at this point G dash. On the surface of the Earth, gravitational acceleration is given by our friend normal small g. Okay, so first of all, how to calculate that? We have to find what is the total distance of the object from the surface of the, from the center of the Earth. Distances are always measured from the center. So distance of the mass from the center is given by distance of the object from the center is given by radius of Earth plus the height, right? Now we will apply our most common law, Newton's law of gravitation. So the force acting between the mass m and Earth is given by G capital M E into small m divided by R plus H whole square, right? This is the formula that we all know. Now what we will be doing, before going any further, what we will do, we will just simplify it a little bit by multiplying with RE square and then RE square m divided by R plus H whole square. Why we have done this? Because we know that gravitational acceleration G is given by G me upon Re square. Okay, so that's why we have simplified it directly. So it gives us G into Re by R plus H whole square into m. This is the force. This is the force between this mass and the earth. Okay, now if the gravitational acceleration at this point is g dash, then this force can also be represented by F equals to mg dash. So we will simply put that is equals to mg dash. So m cancels, so we get g dash equals to g into 1 upon re by re plus h by re whole square. So what we have done, we have taken this re and divided in the denominator, right? So we can write this as g dash equals to g. If you don't want to do that, you can leave your answer over here. That is also accepted as correct answer, but this is a slight fun. So it will be 1 plus h plus re whole square. Okay, so this is the formula. Okay, or g dash equals to g upon 1 plus h upon re whole square. This is the correct derivation, but if they say for smaller height, that it can be approximated. Approximation method I am not doing it, but if you solve it up to this point, you should get full marks. Okay, now as you can see, this is a easier derivation, not super lengthy. But the next derivation, this is more common in terms of exam appearances. Okay, this question has come more times in your final board paper. Okay, final PU1 paper, this question has appeared more times than the other one. Derive the expression for acceleration due to gravity at a point below the surface of the earth. So here we have earth. I will drawing the earth a little bigger because we have to go inside, and we are going inside the earth. We are digging inside the earth using a drilling machine, and we drilled up to a depth of say small d. So we drilled up to a depth of small d. Now remember that whenever we are, earth is solid, it is not hollow by the way. Okay, whenever we are going inside a object, okay, only the mass which is left here, that is important to calculate the gravitational acceleration. Whatever is outside, that is like it is already peeled off, like the cover of the orange I told you. Okay, so this portion does not contribute in the gravitational acceleration inside. Only the mass which is inside this sphere, that will contribute towards the gravitational acceleration. Okay, now what is the radius of this imaginary sphere? That is, radius is re minus d. Okay, total radius obviously is re. Okay, so that this means it will be re minus d. Okay, now here you have to assume that the average density of earth is given by rho. Average density of earth is given by rho. Rho symbol is like p. Okay, if you don't understand how to write rho, what you can do, you can take a line, make it curve and do it like this. So this is also can be considered as rho. Okay, but this is the actual sign which is very close to p. If you don't understand, write a p and give it a tail. Okay, so you can consider this to be a p with a tail. Now what? First of all, we have to find the mass of the entire earth, okay, and also mass of the inside portion. Mass of the entire earth is me, and mass of this portion say m. Okay, so what is the mass of entire earth? Mass of entire earth is given by, how to calculate that? We know the density. If we can somehow know the volume, then we can multiply with volume to calculate the mass. Okay, so if you can calculate the volume of earth and if you can multiply with the density, then we can say that volume into density is the mass, right? Density is mass per volume, so mass will be volume into density. Now what is the volume? How to calculate? So assuming the earth to be a perfect sphere, the volume of a sphere is given by 4/3 pi r cube, right? This is the volume, and the density, if you multiply, you get the mass. Okay, so this is the mass of entire earth. Similarly, tell me if I can write it or not. Similarly, the mass of the inside portion of the earth is given by 4/3 pi okay, 4/3 pi RE minus D whole cube into rho. It is, you don't need to do anything, just write similarly. Okay, similarly, the mass of the central portion or inside portion of the earth, which is at the depth D, is given by this. Okay, so these two calculations are important and we will use them later. Now let's see. So what is the, if you keep a mass over here of mass m, what is the force acting on it? What's Newton's law of gravitation is saying? Newton's law of gravitation is saying that the force will be gm m upon Re minus D whole square. So this is the force of gravitation that is acting on this mass. And again, if the gravitational acceleration at this point is g dash, we can write this as mg dash. Okay, we can write this as mg dash. So from here m cancels and we can write g dash equals to gm by Re minus D whole square. Okay, Re minus D whole square. Now what we will be doing, we will try to replace this m with me. How to do that? For that we have to divide them. So m by me, what we are doing, we are dividing this m with this m. Okay, so what we can write, 4/3 pi Re minus D whole cube rho divided by 4/3 pi Re cube rho. So 4/3 pi cancels, rho cancels, and we get mass is given by Re minus D whole cube divided by Re cube into me. Okay, so this is the mass. Now this mass we will replace over there. Okay, because this mass, if I put this value over here, the calculations will be complicated. That's why the simplification has to be done before, so that we can directly use it during our derivation, and our derivation remains small and clean. Okay, you do not make any mistakes over there. Okay, now put this mass over here. So what we got, gme by Re minus D whole square. So we have put the me over there, so we have to put this also. So Re minus D whole cube divided by Re whole cube. Okay, so we have put this value. So now we can cancel this, right? So 3 minus 2, so this will be cancelled, and we can write gme upon Re square into Re minus D. Sir, there was cube over here, you made a mistake. How could you write square over there? Because I have taken one Re outside, right? I have taken one Re outside, so Re square into Re, right? Why I have done that? Obviously this is our gravitational constant, sorry, not gravitational constant, acceleration due to gravity. So that's why I just wanted to put g over here, that's why I have written it like this. So g dash equals to g into, now simplify this, you will get 1 minus d by Re, right? Divide every term with Re, you will get 1 minus d by Re. This is the expression for gravitational acceleration inside the earth. Okay, so that's why I said you need to do the length of the derivation is almost same except this part. This part is something which is you have to do extra. Okay, this portion you have to do a little bit extra, and that's why it can be sometimes tricky. Okay, now next is numerical question. The escape speed of projectile on the surface is 11.2 km per second. A body is projected with thrice this speed. What is the speed of the body far away from Earth? So first of all, if you throw an object with exact escape speed, then far away from Earth, the speed of the object will be 0. It will neither move it will not do anything. Okay, far away, once it is far away from Earth, the escape speed, if you give a escape speed, then it will be reaching a speed of 0. Okay, so that is that means the potential energy, we already know that total energy will be 0 when you throw it with escape speed, that is U plus Ek, or Ek is given by U. Now U is negative by default, so Ek will be equals to U. So when the object is on the surface of the Earth, if you give it this velocity, then it will escape the Earth. So what is the potential energy on the surface of the Earth? Potential energy of the surface of the Earth is given by half mv square. Remember this. Why? Because if you give this velocity at infinity, the speed will be 0. So that means when you give the escape speed, then that will be equals to its potential energy. That means U should be equals to half mv square magnitude wise. Okay, but the sign will be negative. Sign will be negative. Potential energy is generally negative on the surface of the Earth. That's why sign is negative. Now we will calculate how to solve this question. You have to calculate the initial energy and the final energy. Okay, so what is the initial energy of the system? Initial energy of the system is U plus the kinetic energy that you give it. Okay, the kinetic energy that you give it because of the given velocity. Okay, so this is U plus Ek is the initial energy. What is the final energy? Final energy will be, it will be only kinetic energy. Potential energy will be 0. At infinity, potential energy will be 0, but because you have given more than escape speed, okay, it will still have some kinetic energy left in it. So that's why we have to calculate the velocity at infinity. Now put the values. So what is the initial potential energy? Initial potential energy is half mv square. What is initial kinetic energy? Initial kinetic energy is half m 3v square. Why 3v square? Because it is projected with the thrice the speed. 3 times. Thrice means 3 times. Okay, and that will be equals to half m v infinity square. We are trying to find this v infinity, right? So half m, they will be common and cancel, right? So what we got? Minus v square plus 9v square equals to v infinity square. Okay, so minus 1 plus 9, so v infinity square will be equals to 8v square. If you don't understand, if you have not studied till yet and you don't understand this problem, you can skip it. But if you have a basic idea about escape speed, then you should definitely try this. 2 root 2 VE, and 2 root 2 means 2 into 1.41 into 11.2, which is given in the question. This will turn out to be 31.7 km per second. 31.7 km per second. Okay, so this will be the answer for this question. Now let's move on. Assuming thus Earth to be a sphere of uniform mass density, how much would a body weigh at the depth equal to 1/4 of the radius of the Earth if it weighs 200 Newton on the surface of the Earth? What will be the weight of the same body at the center of the Earth? Let's solve one by one. First of all, the body weighs on the Earth is given by 200 Newton. So surface of the Earth weight is equals to mg, right? That is given by 200 Newton. At a depth d equals to r by 4, 1/4 of the radius of the Earth. That is given in the question. 1/4 of the radius of the Earth, d equals to r by 4. The weight is mg dash. M remains constant. Only g is changing, right? Now what will be the g dash? G dash will be g into 1 minus d by re, right? Now what is d here? D is r by 4. D is r by 4, right? We did this derivation a few moments back. Okay, so r by 4. Now we will put here. What is mg? mg is equals to 200, so 200. Okay, just simply put this value over here and simplify the other term, minus 1 by 4. Okay, RE cancels, we are left with 1 by 4, so 200 into 3 by 4, so it cancels, we get 50, so 50 means 150. Okay, 150 Newton is the mass at a depth r by 4. This is easier problem, okay, taken from your last year's model paper. They have not released this year model paper, so I cannot help you. So this is the 150 Newton should be the weight of the body. Now what about the weight of the body at the center? At center, okay, D will be equals to R, so G dash will be equals to 0, so weight will be equals to 0. Okay, at the center every object's weight is 0, okay, because distance is 0. Okay, the depth is 0, that's why the mass is the weight is 0. So correct answer is 150 and 0 Newton. Next chapter, mechanical properties of solids. Let's see, first question, define stress and strain, mention its SI unit. Very common standard question. Stress is the restoring force developed per unit area inside a body when an external force is applied to deform it. So when you apply an external force to deform an object, then the quantity that is developed inside the object is called stress. It is given by force divided by area and its unit is Newton per meter square. Strain is the ratio of the change in dimension, that is length, volume or shape, okay, of a body to its original dimension when deforming force is applied. So when you deform the force, then the ratio of deformation divided by the original length, volume or shape is called the strain. Okay, strain is a dimensionless quantity. What is the meaning of dimensionless quantity? Dimensionless quantity means it has no unit. So if they ask you define strain and give its unit, then you have to mention strain is a dimensionless quantity. That means it does not have any unit, but you have to mention it. Strain is delta L by L, that is one for longitudinal strain. Okay, now next, define Young's modulus, rigidity modulus and bulk modulus. All three definitions are very, very important. Okay, Young's modulus is defined as the ratio of longitudinal stress to the longitudinal strain. Okay, within the elastic limit, very important, within the elastic limit has to be mentioned for all the moduluses. Okay, so y equals to longitudinal stress divided by longitudinal strain. Rigidity modulus or shear modulus is given by, rigidity modulus is the ratio of shear stress to the shear strain within elastic limit. Shear stress, I already explained the book one. If you apply sideways force to a book, then that gives you the shear stress, and the corresponding strain is called shear strain. So shear stress divided by shear strain is called rigidity modulus. Bulk modulus is the ratio of volumetric stress, that is pressure, to the volumetric strain. Okay, so pressure divided by volumetric strain is the bulk modulus. Now those who will study mechanical or civil engineering, they have to study these things very, very intensely. Okay, other engineering students, those who take engineering in other branches, this will be there, but not to be in an extreme level. Okay, but those who take civil and mechanical, those who are planning to take civil and mechanical, they should remember these definitions by heart, and these two chapters, mechanical properties of solids, mechanical properties of fluids, both will be very, very important as a basic. Okay, that will be a basic chapter. They will go beyond that. Now next, define Poisson ratio, give its limit for it. Poisson ratio is defined as the ratio of lateral strain to longitudinal strain in a stretched compressed body. So sigma equals to lateral strain by longitudinal strain. What is the limit of Poisson ratio? It is between 0 and 0.5. Okay, Poisson ratio is between 0 and 0.5. The maximum value of Poisson ratio is 0.5. It's generally slightly less than 0.5, but it should be greater than 0 but less than 0.5. State and explain Hooke's law. This is also a very common question from this chapter. Hooke's law states that within the elastic limit, the stress produced in a body is directly proportional to the strain produced. So stress is proportional to strain. Stress equals to y into strain. Okay, where y is the modulus of elasticity, that is Young's modulus, shear modulus or bulk modulus, depending on the type of the deformation. Okay, clear? State and explain Hooke's law. This is also going to be very, very important. Next, derive an expression for elastic potential energy in a stretched wire. So we will try to find the elastic potential energy of a stretched wire. Suppose there is a wire and you applied some force on it, and the wire gets extended by a length, say small l. We are not using delta L, I am using small l. So when you apply, original length of the wire was capital L. Okay, so you apply some force and it gets stretched. Now remember that this force is not constant. Okay, whatever force, if you apply some force at the rear end, the force at this point will be 0 and slowly it will start increasing, right? So average force will be given by the force that is acting is not constant, so you have to calculate the average force. Average force at one end is F and the other end it is 0, and if you take the average of that, you should get the average force acting on the entire length, right? This is the average force you can consider. Now what is the potential energy? Potential energy, to calculate potential energy, you have to calculate the work done. Okay, so again, work done, even though the chapter is done, but it will be there in your final exam, and it will be there in this chapter as well. So what is work done? Work done to extend the wire. Work done to extend the wire is given by it will be stored as potential energy. First of all, the work that you do to extend, stretch a wire is stored as potential energy. So if you release it, it should go back to its original length. That's why elastic limit is very, very important. Okay, within elastic limit, this should happen. The W is equals to U in case of the stretched wire. So W equals to U. Now what is work done? Work done is given by the average force that is acting times the displacement. Displacement here is the extension, which is given by small l. So F average into displacement is the potential energy stored. So U equals to F by 2 into L. F average is F by 2. So F by 2 into L. So this is the first initial step. Now what you have to do? Simply what you have to do, you have to start with the definition of Young's modulus, which states that is stress by strain. Stress is F by A, strain is small l by capital L, and you have to find the F from this equation. Okay, so Y into L by capital L equals to F by A. We just did the cross multiplication. This as a whole come here multiplied. So F equals to Y L A by capital L. Okay, F is equal to Y L A by capital L. Okay, now use this F back to this equation. Okay, so it will be Y L A by 2L into another small l. So if you multiply everything, you will get Y L square A by 2L. This is the potential energy. This is the potential energy of the stretched wire. Small derivation, 3 mark will come if this derivation is coming. So first stage is to calculate the average force. Don't forget it. Once average force is calculated, work done is equal to potential energy, and potential energy is equal to force, average force into displacement. Here displacement is equals to the length which is by which it is stressed. So that's why it will be F average into small l, and then calculate the F from Young's modulus and put that back in this equation to get the final value. Now next chapter, mechanical properties of liquids. So this chapter is done. State and explain Pascal's law. Statement: Pascal's law states that when pressure is applied to a confined incompressible fluid, the pressure is transmitted equally and undiminished in all directions throughout the fluid. So suppose you have say a rubber ball. Okay, rubber ball, you the balloon that you use during maybe during Holi. Okay, if you have used that during Holi, you know that. Okay, or you can take a rubber ball and put some water inside it and make some holes. Okay, you make some holes. Okay, and if you apply the pressure inside outside, okay, if you apply some pressure in this rubber ball, what will happen? the water that will come out through all the holes will be equal. Okay, the water speed of water that is coming from all the holes will be equal. That is because of the Pascal's law. Pressure is equal in all direction. Pressure will be equal in all direction, and that's why the speed with which the liquid will come is constant. Explanation: consider a fluid completely enclosed container like in a hydraulic system. When an external pressure is applied at any point, the fluid transmits this pressure uniformly to all parts of the container and to the walls. This means every point in the fluid experiences the same increase in pressure. Okay. Now let's move on. Mention any two factors on which pressure inside a fluid depends. Pressure inside the fluid depends on depth. Okay. Pressure increases with the depth below the surface of the fluid. Density of the fluid. A denser fluid exerts more pressure on the same depth. Okay. So density of the fluid and depth both are on which the pressure depends. We'll do the derivation. Derive the expression for gauge pressure inside a static fluid. The derivation that I was talking about. So we have a fluid. We have done this, right, when we are kids. But again the same derivation we have to do. Only difference is now we will term it as gauge pressure. Okay. And the density of the fluid is rho, height of this is h. Let us consider a cylindrical volume of surface area A and height h. Okay, so what is the mass of this fluid column? What is the mass of this fluid column? So any pressure that is acting over here, any pressure that is acting at this point should be due to the mass column of this liquid. Okay, so first stage is to calculate the force. First stage is to calculate the force, second stage is to calculate the pressure. First we will calculate the force. To calculate the force, we have to calculate the mass. So what is the mass of this liquid column? Mass of the liquid column will be given by the volume of the liquid column. The volume of the liquid column times the density. Okay, volume is represented by capital V. Volume into density is the mass of this liquid column. So what is the volume? So surface area is A, height is h, so volume should be h into A. Okay, any symmetrical object, if you know the surface area, if you know the height, you can calculate the volume by multiplying height into area. So this is the mass. What is the force acting at this point? The force acting on at this point is given by the weight of the liquid column. Okay, it will be given by weight of the liquid column, that is equals to h a rho into g. Okay, now what is pressure? Pressure is defined as force per unit area, that is h a rho g divided by a. So this is h rho g. So pressure is given by h rho g. Now, so this is the derivation of gauge pressure at any point inside the liquid. Derive the equation of continuity. What is the significance of the equation? The equation of continuity means we have a column that is carrying some fluid through it. Okay, suppose the area here is A1, area here is A2, velocity of the fluid here is V1, velocity of the fluid is V2. Okay, now what? So this is the pipe through which a fluid, incompressible fluid is flowing. Incompressible means it does not get compressed. So whatever mass that enters over here, say M1, and whatever mass that exit from here, say M2, in some time delta t, okay, in some time delta t, okay, time is same. So if the time is same, the same time delta t, the mass should be same. Okay, because mass is invariable, right? Conservation of mass. So whatever mass is entering from here in time delta t, the same mass should exit from here in time delta t. So you have to calculate the mass. So how to calculate the mass? Mass is given by volume, okay, into density. volume into density. So what is the volume of liquid that travels or that passes through this surface area in time delta t? How to do that? Okay, previously we had a column, but here no column is there. So how to do that? For that, what we will be doing, we will use, suppose at t equals to 0, this is A1, this is at t equals to 0. Okay, so this is only you are considering this. Now fluid is going in. What is the, in 1 second, how much distance it will travel? We are basically taking this here and we are extending it. Okay, we are not considering what is happening inside. So how much distance it will travel? The distance it should travel is v1, right? Because velocity is that per second. Now how much distance it will travel in time delta t? v1 into delta t. So the distance traveled is v1 into delta t, only this thing. Okay, just consider this surface and fluid is passing through it. So how much, what is the surface area? Surface area is A1. What is the height? Height is v1 into delta t. So what is the volume? Volume should be equals to surface area into height, that is v1 delta t into rho. This is mass, right? Mass 1. Similarly, mass 2 will be A2 v2 delta t into rho. Now from the conservation of mass, m1 should be equals to m2, or you can write A1 v1 delta t into rho equals to A2 v2 delta t into rho, right? So rho delta t cancels, we get A1 v1 equals to A2 v2. This is the equation of continuity. And what does it represent? It represents obviously conservation of mass. Conservation of mass. So equation of continuity represents conservation of mass. Write any two applications of Bernoulli's principle. Lift of an airplane wing. Air moves faster over the curved upper surface of the wing and slower below it. This pressure difference produces an upward lift, helping the airplane to fly. So if you have seen a airplane wing, okay, it designed such a way that the pressure is more at the bottom, so that air is flowing faster over here. This is fast and slow at the bottom. And Bernoulli's principle says that higher the speed, smaller is the pressure. Okay, so because pressure fluid is air is passing very fast top of the wing of the plane, okay, and slower in the lower portion of the plane, what happens is that the plane gets lifted up. Okay, perfume sprayer. So we all use DO perfume sprayer. What is that? How does it work? Okay, when air is blown through a narrow tube, its speed increases and the pressure decreases. This low pressure sucks the liquid up from the bottle and sprays out as fine droplets. Okay, so perfume sprayer or the any sprayer that you use, the sprayer that you use to spray, say your plants. If you have a plant sprayer, that is also works on the same principle. Okay, speed increases, pressure decreases, and that's why the fluid can come through the pipe. Okay, so perfume sprayer also works on the principle of Bernoulli's principle. Now last chapter, thermal properties of matter. Okay, write any two differences between heat and temperature. Heat is the form of energy transferred between bodies due to temperature difference. Okay, temperature is the measure of hotness, coldness of the body, obviously. So this is a energy. Okay, this is a measurement. Energy, you can measure heat, but the process is very complicated. Okay, but you can measure the change in heat energy, whereas temperature can be measured exactly. Exact heat energy of an object is very difficult to measure, but change in heat energy is easier to measure. Okay, SI unit of heat energy is Joule, SI unit of temperature is Kelvin. What is meant by anomalous expansion of water? The property of water by which it contracts on heating from 0 to 4 degrees Celsius and expands on cooling from 0 to 4 to 0 degrees Celsius is called anomalous expansion of water. So you can draw the graph, okay, where if you draw the volume versus temperature, you will see that the volume of water is least at 4 degree Celsius. It is not least at 0 degree Celsius, okay. So when you are decreasing the temperature or increasing the temperature of, say, ice, you melted an ice and you have 0 degree Celsius water, generally what we expect? We expect that lower the temperature, the volume should be smaller as well, okay. But at 0 degree Celsius, the water does not have the lowest area, the lowest volume, okay. But as you go little higher at 4 degrees Celsius, the volume becomes the smallest, okay. Normally for all other liquids, if you see that at melting point, that liquid have the smallest volume except water, okay. Water is, and that's why the life was able to survive on Earth, and if anywhere else the life is there, that is because of the anomalous expansion of water, okay. The property, the explanation can be detailed. Maybe some chemistry teacher can tell you exactly what is the bond length, how it is varying, but I am not doing that. But you should remember that you should thank the nature. Because of this property, the life could be survived on Earth, especially on the poles, okay, pole region, North Pole and South Pole. Life survived because of that in the ancient times also. Because of this property, even when the entire Earth was frozen, inside the Earth water was still there, and because of that we came to existence after a few millennium later, okay. So anomalous expansion of water means, and the volume of water is not smallest at 0 degree Celsius, but it is smallest at 4 degree Celsius. So when you increase the temperature slightly, okay, the volume starts decreasing, and at 4 degree Celsius the volume becomes lowest, okay. Derive alpha V equals to 1 upon T for an ideal gas, whereas the symbols have the usual meaning. What is alpha T? Volume coefficient, okay, volume coefficient of temperature of a gas, volume coefficient of a gas, and it is defined by 1 by V dV by dt at constant pressure, okay. Volume coefficient of a gas at constant pressure, okay. That's why it is given as alpha V, okay. Now how to calculate the volume coefficient? First of all, we have to start our equation at our known relation PV equals to RT. For 1 mole gas, PV equals to RT, ideal gas equation. Now what we will be doing? We will differentiate both sides. P is constant, okay. So V equals to RT, R by V into T. R by P into T. Okay, now P is constant here. What is the meaning of this? This means P is constant, okay. The symbol represents over here P is constant. You have to remember the definition, then only you can find the derivation, okay. So V equals to R by P into T. Now we have to differentiate both sides. So differentiate both sides with respect to temperature. Differentiate both sides with respect to temperature. I hope you have a basic idea about differentiation, because by this time you should have some differentiation taught in your mathematics class, okay. Differentiation is of a function, say fx equals to x to the power of n. So df dx equals to n into x to the power of n minus 1, right. This is the basic form of differentiation, okay. In physics, instead of x, some other variable will be given. For fx, here v is given, and for x, here t is given. What is the power of t? T is 1, okay. So 1 comes over here, 1 minus 1 is 0, so t to the power of 0, t to the power of 0 means 1. That's why there is no t over here. So differentiation is a process in mathematics, okay. If you don't know the differentiation yet, you have to learn at least for this derivation, and later on you will learn more in mathematics class, if not done yet so. Okay, so dV by dt at constant pressure is given by R by P, okay. But here we have to take the P value from this equation and put it over here, because P is constant. So PV equals to RT, or P equals to RT upon V. RT upon V. Right? Now we have to put this P over here. So we get dV by dt at constant pressure is given by R divided by RT by V. Okay, so we get R cancels and we get V by T. So dV by dt is V by T. Now we will take the definition and we will use. So alpha V will be equals to 1 by V, okay, into dV by dt at constant pressure. 1 by V into dV by dt at constant pressure is V by T. So V cancels, we get 1 upon T. So volume coefficient is given by 1 upon T for a given ideal gas, right? So this is the derivation. Slightly longer, but it comes as a 3-marker question, but it may come as a 5-marker if you are lucky. Okay. Mention any 3 properties of thermal radiation. Thermal radiation does not require a medium for propagation. It can travel through a vacuum. Okay, thermal radiation travels in straight lines just like light waves. All bodies emit thermal radiation and amount of emitted radiation increases with the temperature. Okay, amount of radiation emitted increases with temperature. These are the 3 properties of thermal radiation. One more numerical. This is a 5-marker numerical. The base of a copper boiler is 2 centimeter thick and has an area of 0.01 meter square. The steady difference in the temperature between its faces is 5 Kelvin. Calculate the mass of water that evaporates in 1 hour. Given that thermal conductivity of copper is 385 watt per meter per Kelvin and latent heat of steam is 2.2 into 10 to the power of 6 joules per Kelvin. So first let us list what are the quantities that is given. Okay, the length or the thickness is given as 2 centimeter. So whenever you see centimeter, you convert it into meters, and to convert it into meters, do not use decimal, use 10 to the power of minus 2. To convert from centimeter to meter, use 10 to the power of minus 2. To convert from millimeter to meter, use 10 to the power of minus 3. You will realize that this trick will help you in long run, not only in PU1, but once you move to PU2 also, this will be very, very helpful to you. Okay. Now 2 centimeter into 2 into 10 to the power minus 2 meter. Again, area here is given as 0.01 meter square. That can again be written as 1 into 10 to the power of minus 2 meter square. Okay, 0.01 means 10 to the power of minus 2. Okay, so area is there. Now temperature difference, delta T is given 5 Kelvin. Okay, the time given here 1 hour. Time given here is 1 hour. 1 hour means what? 60 into 60 seconds, right? SI unit of time is second. The thermal conductivity of copper is given as 385 and the latent heat is given as 2.2 into 10 to the power of 6 or 22 into 10 to the power of 5. This will help you in calculation. That's it. Okay. Now which equation we will use? Heat transfer per unit time. Heat transfer per unit time through a conductor is given by Q by T equals to Ka delta T divided by L. Okay, divided by L. Okay, or here it will not be L, it will be thickness T. If it is a straight conductor of length L, then we use L. Because here it is a given thickness, we will use thickness. Let me use thickness with a different term because time is also small t. So thickness, let me use D. Okay, thickness D. Okay, so this is the formula that we are going to use. So Q will be equals to K A delta T into small t divided by small d. Now put the values. 385 into 1 into 10 to the power of minus 2 into 5 into 60 into 60 divided by thickness is given by 2 into 10 to the power of minus 2. 10 to the power minus 2, 10 to the minus 2 cancels. 2 into 30 is cancelled, so we get. Now do not multiply it yet. I know you will be allowed use simple calculator, but do not multiply yet. Okay, keep it here. So this is the heat transferred, okay, and heat transferred unit is joules. But you have to calculate the mass of the water that evaporates. So if you give Q amount of water and the mass of water which evaporates is small m, then Q should be equals to small m into L. L is the latent heat of evaporation. Okay. Now from here we can calculate m equals to Q divided by L. So Q, what is Q? Q is this one, 385 into 5 into 30 into 60 divided by 22 into 10 to the power of 5. Okay, so 22 is 11, 2 11s are 22 and 3 11s are 33, 5 11s are 55. Okay, that's why I told you do not cancel it. So you will get this as 15 7 5 0 1 2 3 4 into 10 to the power of minus 5. Okay, so if you multiply all these quantities, you will get 15750, and there will be 10 to the power of minus 5 was in the division, it will go up. So now it's time for us to adjust the division. Okay, it will be 1.575 kg. Okay, 1.575. I think there will be one more extra zero. Somehow I missing it, or there will be one more term, but if you check it, you will get that as 1.575 kilograms. Okay, this will be the answer for this question. I don't think this line is correct, so let me erase it, but the final answer will be 1.575 kilograms. Okay, so let's see the answer. Yes, 1.575 kilograms. You can check the answer from here, but be careful with 10 to the power values. Exact problem will not come. This is from again from your last year's model paper. This year they have not released any model paper for PU1, but this question came last year in many colleges. Might be they are going to give this question in your FA2, so be prepared. Okay, so this is the end of this lecture. If you have any more doubts, any questions, please mention in the comment below. These questions are selected based on their importance. There are many other questions that can come from this chapter. If I want to teach everything, this will take at least 1 to 2 weeks time, but we do not have that time. These are the important selective questions which are very, very important, and if you practice them, definitely you should score at least 30 marks in your FA2 exam. Okay, all the best. I'll be back with more few PU1 lectures. Till then, bye.